I am Danish. I'm an engineer at Waku, and we're going to be talking about communications today. So over the past few decades, we've seen internet protocols evolve, but privacy isn't something that these protocols essentially solve for. Your social interactions, by default, aren't anonymous on these platforms. They're linked, your interactions are linked with IP addresses, which arguably can be solved by using certain strategies. And these platforms require KYC of sorts, so maybe email verification, phone verification. This exposure can lead to censorship, surveillance, and of course, like you're hindering your freedom of speech. Let's say hi to Waku. So Waku is a family of these censorship-resistant and private protocols that enable privacy-focused communications. Some of the things that Waku really stands for is private communication. What that means is your interactions with the protocol are anonymous. It's adaptive. What that means is you can use different type of devices, be it a mobile phone, be it an extensive VPS. So you have a choice and flexibility in the terms of devices you interact with. It's censorship resistant, which also ties into the privacy argument. It's scalable. So we recently implemented sharding on the network, which helps scale the network to millions. It is modular, so it is built on libp2p, which is by the Protocol Labs team, and is extensively modular. What that means is you can pick the pieces that you want to use for the network, for your node. You can use your own sort of encryption. You can use your own sort of discovery strategies, and so on. It also has rate limiting, which is kind of a cool feature for a peer-to-peer network to have. And we'll talk about rate limiting and spam prevention for the network going into the presentation. So these properties sound pretty cool for a chat application, right? But Waku is much more than just chat and can be seen as a generalized comms layer. Some of the applications can include gaming, marketplaces, state channels, and anything that can benefit from peer-to-peer and decentralized communications. So who here is familiar with this diagram? Looking back at the history of Ethereum, of course. So this was included a lot and talked by Gavin Woods, the co-founder, co-creator of Ethereum back in the day. And this essentially talks about how the original cypherpunk vision for Ethereum, where Ethereum was to be used as the contracts layer, Swarm for file storage, and Whisper for communications. Q2 2024, Whisper was extended by Waku v1, which a few years down the line was upgraded to use to Waku v2, which uses libp2p. And today, Waku is continuing to evolve. We have sharding implemented. We have things like spam prevention in the works. So let's look at what makes Waku. So two parts. The first, the protocols themselves. And everything is available on rfc.wac.dev, which is the research entity, and everything is open source. We have our implementations available in TypeScript, NIM, Golang. There are Rust bindings available, C bindings available, and React hooks, which ties into the TypeScript implementation. So looking at the protocols, everything is pub/sub. So every message that is sent out to the network works in a publishing subscriber way. Light push is actually the publish part of the protocol. Everything gets sent out to a particular content topic. Filter is used to subscribe to a particular content topic, and store is a temporary storage layer that we provide with Waku. This is how a message traversal would usually look like, with multiple content topics and different devices sending out messages into the network. This is the format for how a content topic would look like. For example, you want to have your application name of the version, the content topic name, and encoding. And in action, a message gets sent out to a content topic using light push and is subscribed with filter to different peers. And The store protocol allows for a temporary storage layer for these messages if you do not want to keep the ephemerality. The message structure looks something like that, but what we're really interested is in the payload, which is of arbitrary data type, and that really allows you to be very flexible with what you can and cannot send on the network. Moving on, we have a lot of different peer discovery strategies within Waku, and it is built on top of libp2p, so everything is pretty modular, so you can choose to implement your own peer discovery strategy. Talking about Relay, this is really the backbone of the entire network. It is an extension to libp2p's gossip sub, the same protocol that is also used in Ethereum clients. And RLN Relay is a new addition, which is an extension to Relay, but also uses rate-limiting nullifiers, which we'll talk about more in a second, which helps and ties back into the spam prevention and rate-limiting part of the protocol. So a normal message using Relay would look something like that, and this is similar to light push and filter, what we just saw. This is Bob sending out a message to a content topic using Relay, and Alice, John, and Charlie happily consuming this message. Now let's say Bob decides to be a little more malicious and sends out, or kind of wants to spam the network, so he sends out multiple messages into the content topic. Now Alice, John, and Charlie aren't happy, the most happy, because, well, Bob is anonymous, right? Nobody actually knows who Bob is. And this is one of the problems with peer-to-peer anonymous networks, which is spam is a problem that nobody really wants to talk about. And then, moving on, Bob decides to spam even further, right? And Alice, John, and Charlie are still very, very confused, and Bob just decides to just go for it, right? And we don't even see Charlie anymore, right? Charlie just disappeared, and Alice and John are just, they're all over the place. So this is what the network looks like without RLN, which is with spam, right? RLN stands for rate limiting nullifiers, and if we look at this diagram, we see Bob, being the malicious actor, sends out these messages into the network and spams the network, which essentially causes these certain nodes to just get burned down. Moving on, now that we talk about RLN, if the same message traversal was to be included with a certain zero-knowledge proof that nodes can verify, and based on certain properties like how many signals per epoch is being sent out, these nodes can verify the proof, and if the proofs do not match, or if there's some problem with, if spam is detected, these messages can be dropped and the connection with the nodes can be dropped. And this can be really seen with these statistics where the proof generation time, we increase the average message size, but the proof generation time generally revolves around 15 milliseconds. Similarly, for proof verification time, it somewhere stays around 20 milliseconds. And this is a really interesting one. So here we see the malicious actor sending out almost 2,500 messages per minute, right? And we see that the connection, right at that instant, the connection with that node is dropped. And this is essentially what RLN is solving. And this ties into the Waku network. This is the RFC for the network. And you can essentially run your own node today in a permissionless way. We have certain docs that can help you get started. And the easiest one is to either set up a dApp node or run your own Docker container. And this is a very, very cool demo of how message is being traveled in a live way by one of my colleagues, Alvaro. Let me see if I can try to play this. Yeah. So this is how a message is traveling, or there's something up with the demo, but yeah. So we can see, basically this is a live view of how a message travels across the network, across different nodes. And these are some of the resources that can really help you understand these things better and maybe try things more hands-on. Docs.waku.org can give you a glimpse into how you can use Waku as a developer, or if you choose to run a node. Ideas.waku.org are some of the projects that it's like an idea board that we see getting built out with Waku. And Awesome Waku is a GitHub repository that houses all the different hackathon projects or different side projects that are built using Waku. Some of the projects that currently use Waku are XMTP, the Graph, Status, and Railgun. If anybody's interested, feel free to scan this QR and you'd be jumped right into the docs website, which will house most of the information that we talked about. And everything we do is open source and communications happen in the Discord. So if you're interested to just observe, lurk around, contribute, feel free to join the Discord. And that's it for me. Thank you.
Thank you, Danish. Do we have any question for Danish or Waku?
Does Waku do encryption?
Very good question. So we do encrypt connections with the noise protocol. But again, since Waku is very modular, you do have a flexibility of using whatever connection encryption layer you want. Saying that, we also encourage developers to really use encryption strategies of themselves on the application layer. So on the protocol layer, we do have an option of using noise. But again, we encourage developers and application consumers to sort of use their own encryption strategies.
Okay, thank you.
Does that answer your question?
We can add another encryption layer on top of Waku, right?
Correct.
Okay. How does it compare to like WebRTC?
So WebRTC is a family of protocols, right, which is also peer-to-peer, but natively with WebRTC, you do form, it is a way for you to connect to a different node, right? It is a connection layer. Waku, within Waku, you can choose to use WebRTC as a means to connect to another peer. You can also choose to use TCP. So you can use different protocols that you can connect to different peers, dependent on what the other node supports. For example, if you're using Waku in a browser environment, WebSockets is a strategy that we generally recommend. WebRTC is something that is still possible. Similarly, UDP is something that's still possible. So all these strategies are possible, but this is something that in the browser environments we're experimenting on and haven't really tried. But considering it is libp2p and considering that you have the flexibility of using whatever, you should be able to experiment and just try.
So Waku is can use many protocol underneath.
Right. So think of Waku as the closest analogy to a Web2 protocol is a message bus, right? So I wouldn't really say TCP IP as an analogy, just because it assumes certain message reliabilities and acknowledgements that Waku does not do. So Waku is actually an abstraction over these certain protocols. It is built on top of the gossip sub protocol by libp2p, right, which is again pub sub. So when you're connecting one node to, when you're connecting your node to another node, you can choose to use whichever protocol you prefer, which is supported, right? It can be WebRTC, it can be TCP, it can be UDP, it can be WebSockets.
Is there some financial incentive for relay provider?
Great question. So we have been permissionless for forever almost, but incentivization is something that is currently is being researched, and it is part of our roadmap for this year, probably by Q3, Q4. So it is something that is being researched, but currently Waku nodes are not being incentivized. So we do have certain operators that are running their nodes, and if you do run into, and we're going to be opening a form of sorts to actually just keep a log of all the operators that currently exist in the network. So if you do run into any troubles running your own node, Discord is a great place to just bounce your questions off of.
Okay, thank you.
Of course, thank you.
More questions?
So you mentioned RON is used in the Waku.
Sorry, can you say that again?
RON
Yes.
is used. So would user need to deposit before using the chat?
Right. So we are currently deployed on testnet. We're currently deployed on Sepolia. The exact specifics of slashing is also being researched. So the idea is, of course, you deposit or you stake certain amount of tokens into the contract, and that essentially gives you a membership ID. And whenever you send a message into the network, you generate a proof based on your membership ID and some more parameters, and that is verified by the other nodes. And if you are seen to be a malicious node or a bad actor, you will be slashed. But the specifics of it is currently being researched, and everything is open source, so we encourage contribution if you're interested in this particular part of it. The Discord and the forum is a great place to be at.
And if user only spends in the certain topic, would it still be slashed, or is it will have limitation for each topic, or it's overall?
So if I understand that right, you're asking if the node can choose the content topics that it cares about?
Yeah. I mean, user might only spend in the certain topic instead of the all topics. So would RON work on each topic? I mean, work the rate limit per topic, or it is overall for all topics?
Yeah, I see. So that's a very good question. You, as a node, when you're generating your proof, certain criteria need to be met. For example, the number of messages per epoch that you're sending out, which, for example, if it's a minute, it is independent of, as far as I know, we'd have to check the circuit, but it is independent of the pub subtopic or the content topic that you're sending out the message to, and it is linked to your membership ID, your commitment, and the epoch and the number of messages that you are sending.
I see. Thank you.
To what extent, Panda?
Sorry, can you say that again?
To what extent does the graph depend on Waku?
Yeah, of course. So Graph Ops, one of the sister companies of the Graph, which essentially uses Waku to decentralize their indexers. So indexers need to communicate with each other, right? And prior to Waku, they use some sort of central comms to facilitate their communications, and switching out to Waku, they essentially have their indexers communicate with each other using Waku.
Do we have more questions? Thank you so much,
Perfect, thank you.
Danish.